Ready? Ready? All right. So we talked about inheritance, and we said inheritance is essentially um, uh, getting a design that we already had and um, build something on it. We said that inheritance is not what we call in comparing real life. They say I got something like I have my mother's eyes, I have my father's ears. That's not inheritance at all. Okay? Inheritance is class design. Inheritance, me being a mammal. That's what inheritance is. Okay? So inheritance, table being a furniture. That's inheritance. So when you say furniture, there are so many things coming to your mind. And it's a common thing that all furnitures have. Furniture can be a chair, can be a table. That's inheritance. Inheritance is receiving a design and based on the already existing design, add features to make it suit new circumstances that we have in our business logic. We started talking about inheritance with an animal. We said as an example, I started an animal class, and I said an animal is a thing that has a name. It has a constructor that you can put some name on it. Forget about copy constructor and copy assignment. That has nothing to do with what we want to talk about. And then we had a setter and getter for the name of the animal. An animal can act, move, and make a sound, and we put a destructor over there to trace what we have. There is no need to have any type of rule of three applied in here. We just did it so you can see. So after that, I said, okay, now that I have an animal, I would like to have a cat. So what I did in my next design, I created a cat out of an animal. So animal was the original thing. A new feature got introduced. A new access modifier got introduced called protected. We said since now we have inheritance, we have one class getting all the features of another class. So it's not only protecting the properties of a class from outsiders. Now I have to refine it for those who are inheriting from me. So we said when you are saying private and public, that's for everyone. So when you say something is private, no one can access it. When you say public, everybody can access it. When I say everybody, I mean any other code in your C++ program. When you make something private, the code in your C++ program cannot access it. When you make it public, the code can actually access it and use it. But when you say protected, protected essentially means private for everyone, public for children, public for derived classes. And I gave you the example about a dad having a Ford Festiva and a Porsche, which one you're going to get. So you remember that, right? So that's that. So that's what we did. And we said, when I inherit out of another class, so in this case we have cat.h. So as you see, at left side I have the animal, and at right side I have a cat. So essentially at line 7, by saying cat, class cat, column, public animal, I'm telling a cat is an animal. So this column public means is A, okay? And then out of that thing, we said we add one feature to the cat that the animal doesn't have, and that's number of lives, okay? So we created number of lives over there. We added cat has everything that animal has, which is a name. It can set or get its name. It can act, it can move, it can make a sound, even if nothing is implemented over here. So if all the actions of the cat is removed, cat is still capable of doing everything that an animal can do. Essentially, it inherits all the features of the animal. If cat implements an action that animal does it too, we call that? Overriding, that's perfect, yeah, overriding. So essentially, overriding is what we called in structured programming as shadowing. In shadowing, we said if you have an outer scope, you have a variable. In an inner scope, you create a variable with the same name. The inner one shadows the other one. It's the same thing over here, but because it happens in hierarchy of inheritance, we call it actually overriding. So act over here overrides the act of the animal. Move, I removed it intentionally to show you that a cat still has a move, but the move is what is an animal does. It doesn't add any features to it. Sound over here is overriding the sound of the animal. Play is something completely new, which means if you create an instance of animal, it doesn't know what a play is. But when you create an instance of a cat, it's an animal that can play. You okay down to this point? Then talking about all these features, we mentioned exactly what is a and has a relationship is in the previous day, which was in notes, I believe. So I created a bicycle and a motorcycle. So we had several classes. We had a bicycle class, we had an engine class, we had a mechanic class, we had a motorcycle class. When we were talking about inheritance, we said motorcycle is a bicycle. So that is a relationship. But motorcycle has an engine. This is not inheritance. This is property. This is attribute. I have a head. I have two hands. A human being is not hands. A human being is not head. You know, head is part of my body. That's what it is. So this is something extremely important to realize in your design. In your design, when you are creating something, you need to see if it's an is a relationship, it's inheritance. If it has a relationship, it is not inheritance. You should not inherit it. You should bring an attribute of it inside your class. In this case, was an engine. And then we talked about how access is happening. And we said if I have a class mechanic should be able to access the engine. Therefore, that's friendship. And we said friendship should not be applied to any methods. Methods are not friends. The only thing can be a friend is a class. And the example was brought out by saying, okay, can a motorcycle access an engine? And I said, no, it can't. The private and public access modifiers of the engine dictates what a motorcycle can access in an engine. Engine has lots of internal functions that are private and nobody uses. It has public properties that the motorcycle uses to use the engine. So who has access to an engine? We said a mechanic has an access to an engine. That's why a mechanic becomes a friend of an engine. And that's why we have a forward declaration of it. So this forward declaration tells to the engine, hey, there is a class called mechanic that is your friend. The definition comes later. It's exactly like a function prototype. We good down to this point? This is essentially what we talked about last time. Now, more in detail with cat and an animal. When we are dealing with overriding, we have a couple of choices. When you override a method of a base class, you either want to completely change it, or you want to use the original one and add some features. So there are two different types of override that you do. Number one, you say, I do not like the one that my base class has. I want to change it completely. It's like you have a vehicle and a vehicle moves. Now, if your vehicle is a car, movement is going on tires on a street. If your vehicle is an airplane, it's flight in the air. So they are two completely different things, the movement of a vehicle, when it gets inherited forward. That's when you want to override, okay? But sometimes, you want to just add to the features of the base class. Let's say I have a label. A label can be printed, right? And then I have, what is that plaque on the class? That's a label, right? This. It has a title, but it has a room number too. So a plaque of the room number is a label that when it's printed, it not only prints the title, but also prints the room number. So as you see, you have to reuse the print of the label and add a feature to it. You don't want to just throw it away. That's when you actually modify. To demonstrate that, we did this way, we put these things in here. So for the animal and the cat, so when we look at the source code, when I come to acting, as you see, the act of the cat completely does a thing of its own. It has nothing to do with the act of the animal. This one says act like animal. This one says act playful. It prints the name of the cat and says the cat. Act playful, Garfield the cat, or whatever. Okay? Tom was the cat or Jerry? Which one? Anybody knows? Tom is the cat, so act playful, Tom the cat. Okay? We have only one person who's old enough to know what Tom and Jerry is. Anyway, so, okay? So that's that one. But when we are talking about sound, I'm going to say, hey, the sound of an animal still can be used. So a cat sounds like an animal, but that thing is meow. So I'm going to say, first call the sound of your base. Now, this is not, remember, the sound that over here doesn't get called with a dot because dot is for objects. Here, sound is part of you. It's the animal part of you, as you are a cat. Therefore, you don't use a dot. You use an scope resolution. You're saying animal part of me has a sound, first call that. Then do these things. So when somebody calls the sound, it first invokes the sound of the animal, and then whatever it does. This means I'm using the parents, the derived classes features, and then add stuff to it. Obviously, play is a completely different ballgame. Play is something that is completely separate, has nothing to do with the animal. Are we okay down to this point? So we got down to this point. Now, let's see what are the problems with the design that we had. Any questions down to this point? Problem? You asked about the quiz? If there's no quiz, there's no quiz. I'll explain to you later. Are we all good? Give the microphone to the lady because you answered already. Okay. All right. Constructor and destructor?
For inheritance.
Oh, yeah. We'll go through it. I haven't talked about it at all, so I'm going to go through it. Initialization area stuff, I'm going to go through it. Okay. So this is down to this point, everything is fine and dandy. So we are all good. But what happens actually, when actually a derived class gets created? I always mention this thing. Nothing is automatic in C++. Okay? If you don't mention something, it becomes defaulted. That's all. So if you are creating an animal and you don't mention to the compiler, sorry, when you're creating a cat and you are not mentioning to the cat how the animal is supposed to get created, it's just going to create a default an animal and stick the cat to it. So you have to make sure that you tell to the compiler what needs to be done. It is completely your choice. And if the base class does not support a default constructor, then you have no choice but to mention how to create it. Otherwise, it won't create it for you. Remember, when you don't mention, it's going to call the default constructor of the parent. If the parent doesn't have a default constructor, you get a compiler. It says, hey, that's not happening. You cannot do that. Okay? So the default, I'm sorry, I keep calling it default constructor. The best terminology for it is no argument constructor. Okay? So default constructor, it's better to say no argument constructor. A constructor that has no arguments. That's what a default constructor essentially is. So if you have a regular one argument constructor and that argument has a default value, then you do have a default constructor because it can be served as such. So creation of the constructor of a derived class. The constructor of a derived class can dictate what to be called, what to be used for the base class, for the creation to happen. And all those things happen in a place, in an area, we call it initialization area, which is essentially, let me bring the other one in. Okay, so when you want to create any type of a class that is derived, so if this motorcycle of mine has a constructor and I want to create it, the area over here is where you initialize different parts of the derived class. The area is right after the closed curly bracket of the constructor and the open curly before the body begins, because that's essentially what it is. Anything you write inside the body of the constructor, anything you write inside the body of the constructor to set the values of the attributes, it means it will happen after those attributes are created. So if my engine over here, for example, has some kind of a size over there like that, I cannot over here say, I don't know, I don't even know how to do that. I cannot say engine 1, 2, 3. I can't do that. Doing something like this is going to cause error because engine doesn't have a default constructor. Because I wrote it inside the body of the motorcycle, before it wants to get created, it has to create the engine. And because engine doesn't have a default constructor, this is going to fail. This must be in the initialization area. So in here, I have to mention now I'm fine and dandy, which means it says before motorcycle is created, set the engine to be 1, 2, 3 in size. Okay? Going back to the cat thingy. Although it is the default constructor of the cat, what I'm saying, when a cat is defaulted, call the one argument constructor of animal and write something in it. I can do that. You don't have to default the base. You can do anything you want to do with the base, as long as you mention it how. If you do not mention it, animal will be defaulted if no argument constructor is available. Other things that you can set up, in initialization area is the attributes of the class. So as you see over here, my cat has a number of lives. Not only I can initialize the animal part of me, but I can actually set the number of lives to 9. Now, it could be with curly brackets or parentheses. They're all the same. Okay? So I could put over here. Actually, I did it for the other one. So as you see, the other one is doing it that way. So now I'm saying cat, the name, number of lives. I'm passing the name to the animal. I'm passing the number of lives over. One important fact that you need to know about initialization area is that the order of initialization must be exactly the same as the order of the attributes in your class. Some compilers will give you warning for that. Okay? So first, inheritance. If I had 3 different attributes, the first one should have been over there first, second one second, third, fourth. Visual Studio won't tell you anything. But if you put it on GNU compiler, it's going to give you a warning. So be careful. So that's initialization area and how it's created. And this applies to anything. So if you are in later on, we're going to learn at the end of the semester, we're going to have derived classes with resources, which essentially you have a class that has rule of 3 because it has dynamic memory allocation. You inherit it to another class. Now, if the inherited class is getting copied, what's going to happen? How you want to handle this? In my opinion, there is no new lecture over there because you know how to invoke constructors. Just take a look at the constructor of your child, of your derived class, create the copy constructor of the derived class, and mention what needs to happen in the initialization area. Any way you want to handle it. There is no problem with anything. If you want, you can invoke the copy constructor of the base. If you want, you can invoke any constructor of the base you want. Or you can, even if you want, you can default it. And if you don't mention it, what's going to happen? It's going to be defaulted. Everything's identical to this, so there's no need to. So these essentially covers the syntax of inheritance and how to initialize and everything. Now we're going to get to the part that there's going to be trouble with inheritance. And I'll tell you what's the trouble, and I'm going to tell you what is the remedy for it. Okay? So first, let's create the problem. Then we're going to talk about the remedy. Any questions down to this point? Suggestions? Objections? So I have the cat. I have the animal. Everything's the same as we had for the other one. Over here, I went even further. So setting the name is completely private, which means even the children cannot access it, which means only animal can access it in here. Animal can set the name, not the. And to get the contents of the name, only children can do it. Okay? Because logically, you never ask an animal, what is your name? You need to invoke it. Anyway, you'll see. So, and the implementation is exactly the same. So it has all the good stuff that it has, as you see. And the cat is implementing very clean and nice with no comments. It overwrites the move. It overwrites the sound and reuses the sound of the parent. And plays, and destructor just shows the destruction if the debugging is on. Are we all good down to this point? Now let's take a look at the main in here. And we need to walk through the main very carefully. So So I'm creating a cat. When the one argument constructor of cat is called, it goes to the one argument constructor, and over there I'm dictating it to call the one argument constructor of animal. So the name that I passed over there as Pepper is going to go back to the animal. The animal will set the name to Pepper, and it's going to say creating Pepper the animal. Now that the animal part is created, it comes and continues with the rest. Now number of lives is set to 9, and it says creating Pepper the animal as a cat with 9 lives. We're good? All right. So my name is Fardat. You can call me Mr. Solimanlu. Why? Because that's my family name. That's my father's name or my mother's name, right? It's the same thing with all the inherited objects. Inherited objects can be referred to or point to with their base pointer. So I can have an animal pointer and put a new cat in it. I can. Because cat, by definition, is an animal. Therefore, an animal can point to a cat. We go down to this point. Okay? The problem is that my father was actually a teacher too for a while. He taught mechanics. So if you actually call me Mr. Solimanlu in an object-oriented world, if you say me, Fardat, teach, I'm going to teach you C++. But if you, in an object-oriented world, you tell me, Mr. Solimanlu, teach, I'm going to teach you mechanics. Because now you are invoking the teach of my father, not me. That's the first problem with inheritance. I created an animal and put a cat in it, and also I am referring to a real cat with an animal reference. So as you see, AP and AR are animal pointer and animal reference pointing to 2 cats. One of them is a cat that is created over there statically, and the other one is a cat that is created dynamically. So the cat that is pointed by animal pointer doesn't even have a cat reference at all. It is only referred to as animal. But the first cat is referred to in 2 different ways, as a cat as P or an animal as AR. Are we okay with this? An animal is the animal. We don't care. Now let's continue. So if I say P act, it's going to act like a cat. If I say move, it's going to move like a cat. If I say make a sound, it's going to make a sound like a cat, right? We know AR is the same thing as P, right? But if I say, hey, animal, act, now it's going to act like an animal. It forgets it was a cat. Sound, move, everything becomes an animal. So Pepper is no longer a cat. It lost all its advances that we created, all the inheritance. So remember, when you point to a derived class using its parent's class and you don't do anything, it's like done just with no filtering of any kind, it will forget that it was a derived class. It becomes a base class, literally. Okay? Same thing with the animal pointer. And down to this point, let's say, okay, fine, just make sure when you're creating a cat, call it a cat. An animal pointer does the same thing. But the problem becomes critical when you delete a cat that is only pointed as an animal. That's dynamic, right? I have to delete it not to have memory leak, correct? When I say, hey, delete the animal, compiler doesn't know it's actually pointing to a cat. So what it does, it only deletes the animal part. And the cat part remains as memory leak. That's awful. So if I actually run this, you will see that it says removing Tom the animal. Tom wasn't the animal. It was a cat. And if I continue, the cat part is not deleted, and I keep going to and you'll see now animal is removed perfectly, and Pepper is removed perfectly because Pepper was created as a cat. So when the compiler destroys it, it's removing Pepper the cat, removing Pepper the animal. So the animal part and the cat part are deleted. No memory leak. Okay? Are we okay down to this point? Are we okay? It's an extremely easy fix for this. Okay? It's a very, very easy fix for this. The fix is when you are creating a class, now I want you to really, really, really listen to me. When you create a class and you suspect this class will be the base of another class in future, you should look closely to all the methods you are writing and think, does this method need to be updated and upgraded later? You have to think. Then you have to write in front of it, this thing is upgradable. So the compiler knows if a derived class is pointed by a base class and you are calling a method and that method is upgradable, it should look to see if their new version exists and call that one instead. How do we do that? What is that upgradable keyword for it? That upgradable keyword is called virtual. As you see, the very first thing that I did virtual was the destructor. As a matter of fact, as of today, till the day you die, when you are creating a destructor for a class, always make it virtual, as if it's in its syntax. Because if you just create an animal and the destructor is virtual, when it wants to delete the cat, delete the animal, okay, the destructor is virtual. Is there a newer destructor? No, because it's just an animal. So it's going to call that one. But if you create a cat and you want to delete a cat using the animal pointer, now it says destroy the animal, but the destructor is virtual. Is there a newer version? Yes. Cat's destructor. So it will destroy the cat. And because cat has animal in its belly, they all die. So all destructors must be virtual with no exception. Always. Remember that. From now on, it's actually an error, a mistake. If I see, go back to your menu, go back to your stuff in your, when you are upgrading to the next milestone. Make sure any destructor you have, if you have any, you have to make them virtual. Okay? Remember that. Although we don't want to inherit the menu to anything, who knows, maybe one day somebody will do. If that's the case, we want to make sure that happens. So I'm going to remove this because this stage, it's supposed to remain this way, and I'm going to go to the next stage. Which is virtuals. Now, if you look at the animal over here, I'm saying I have an animal. The act is virtual, which means if the derived classes overwrite the act, it's guaranteed that in any case, no matter how you call the act, the latest version of it will be called. In fact, that's the definition of the interview answer for this. When you are going to find a job and they want to see if you know C++, they ask you what is a virtual? What is virtual? You have to see virtuality guarantees that the latest version of a method or action will be called, no matter how the object is referred to. So what does virtuality do? Latest version of the action will be. It's always like that. Now, I did not make the move virtual, which means I want animals to move as animals all the time. So if I have a bird out of this animal, and I tell to the bird, move, it won't fly, it will walk. Whatever, okay? You see what I'm talking about? So I don't want it to be upgradable, which means if you are referring to me as animal, I'm going to act this way, no matter what I am. So you can do that. But sound and act are virtual, which means, now if I go back and run it one more time, I don't know what the main is, we're going to find out. So I have animal, this time I have a rat, okay? Oh, the debugging is false, I have to make it true, sorry. So as you see, now that's created, this is created, now I'm creating, in a cat pointer, I'm holding a cat, in an animal pointer, an animal, and a reference. Now I want you to pay attention. Those note takers, the first note that you should have taken was when virtuality guarantees that the latest version of a method is called. Number 2, virtuality only gets activated if you have a derived class is referred to by its base pointer or reference, only. My virtuality only comes to action if you call me Mr. Suleiman. If you call me Fardad, then I'm me. There is no virtuality here. So if you call a class using its own reference or pointer, no virtuality. Doesn't mean anything. Virtuality only comes in action when you have a derived class pointed to or referred to by its reference or by its base's reference or pointer. So in this case that I have a cat pointer pointing to a cat, who cares if something is virtual or not? Because virtuality is moot. The only place that I need to look for to make sure virtuality applies or not is when the animal pointer is pointing to a cat or an animal reference pointing to referring to a cat. Now we can actually see what happens. So in the case of animal to animal, again, who cares? Everything's the same. P-cat, same. It's a cat to a cat. C-cat, it's a cat to a cat. I don't care. As soon as I come to the animal reference acting, now I have to see what is virtual. Because act is virtual, it will go actually to the cats, even if it's an animal reference. But move, it was not virtual. So it's going to go to the animals. Sound was virtual, so the latest version will be called, which is cats. And the exact same thing for the animal pointer. And the good thing is that deleting C, do I need to care? No. Because it's a cat pointed by a cat, I'm deleting cat, who cares if something is virtual or not? The other one, I have a delete for an animal that is pointing to a cat. Now, when the delete is called, it actually goes to the latest version of the virtual, of the destructor, which is cats. And therefore, when cat is deleted, it removes everything. And it comes back. Now, I created a tickle. So you tickle an animal, okay? When you tickle, what happens? Okay, it makes a sound and says ha ha ha, whatever, okay? In tickle, I have an animal reference. What does it mean? It means I do not need to write the tickle for the cat or any other animal at all. Why? Because the sound that is being called over there is virtual. No matter what type of an animal I pass to tickle, they will act properly. They will act the way they are supposed to. So when I come for the first one, when I'm tickling A, that is an animal, it's going to sound like animal and it says ha ha ha, right? But when I'm tickling the cat, in here it's an animal. But because it's an animal reference pointing to a cat, the latest version of sound will be called. Do you see any type of function overloading here? No. The functions are identical. But when you execute it, the cats will be called. That is pure polymorphism to the bone. Function overloading is a fake polymorphism. It's fake polymorphism because it just attaches the types. So when you have a foo with an integer and foo with an integer and double, the first one is foo int, the second one is foo int double. So the names are different. They're not the same. Casting, same thing. It's just changing the type temporarily. This one is actual polymorphism because from here, a person who looks at this code has no way to tell that this sound will be called properly with no interference. And it will be chosen properly based on the object that is referred to by that animal. And the correct version will be selected automatically, hence doing the same thing in different ways. That's true polymorphism. Are we okay with this? And that's virtuality to you. Okay? So, say you want to overload the insertion operator to print an object on cout. Okay? And I said, never make it a friend. Remember that? I said, use the display in it. So create a function called display and call the display in your insertion operator overload. If that display is virtual, you don't need to overload it for any descendants of that object anymore. You just overload it for the base, and because the display is virtual, all the descendants of that object will be displayed perfectly. And that's another beautiful thing. Lots of coding will be saved. You don't need to do it. Well, I'll show you the examples in a moment. And then we go over here, and we're done. Are we okay down to this point? Which is going to bring us to the other one. Can a human being talk? Can they? So, if I bring somebody who you don't know right in front of you, can you tell me how that person's going to talk? But you know it talks. Why can't you tell how that person talks? Because you don't know which nationality it comes from. We don't know what language it has, right? That comes later. So when you are designing a human, you should ignore talking? No. When I'm designing a human, I'm going to say, human, these are the actions. It can walk, it can talk, it can do whatever a human can do. But some of those things should be implemented later. Do we have a human being that cannot talk? Is it possible? No. Any human being with any condition talks in some kind of a language, even if they have never been in civilization or if they cannot talk, they use sign language. Everybody can talk. So talking is a must. So if you are creating a human out of my class, you must implement the talking. Otherwise, that human is not human. Do we agree? That can be enforced with virtuality. How? When I create an animal, yes. Because I didn't run it. I didn't press the F10 and continue. I just stopped. I stopped halfway through execution. It was my mistake. I was pressing F10, and as it executed, I got happy, and I didn't do it. But yeah, it would. Okay. So what I wanted to do? Yeah, I wanted to go to the other one. So now if we look at the animal over here, I'm going to say an animal can make a sound. Look at that thing over there. You see that? Equals to 0. It means an animal can make a sound. I don't know how. Which means in the animal source code, there is no sound function. So we call that a pure virtual method. So pure virtual method is essentially a wish list. When you are designing something and you know that this class needs to be able to do something like this, I don't know how yet. You make that not only virtual, but also pure virtual, and you put equals 0 in front of it. So what happens, the method becomes not implemented, becomes incomplete. Your class, in fact, becomes incomplete. The class is incomplete to be created, but it's a complete design. Please understand the difference between the two. When you create a pure virtual method in a class, the class's implementation is incomplete, as if with human. With human, without a talk, I cannot instantiate a human. I have to first make that human, I don't know, I know my ethnic thing, so a Persian person who can speak Farsi, and then now I'm okay. So I inherited in 3 ways. So 2 levels of inheritance. Even if I create a Persian human, still there are hundreds of languages that I can apply it to. I can't still say anything. So still it's not complete. A Persian human being, a Chinese human being, they can talk. But still I don't know if it's Cantonese, Mandarin, what is it? Like, and I know there are like thousands of other different dialects over there that I have no idea about. But still it's incomplete. And that's what happens with virtuality. When you create a pure virtual method in a class, the class is not instantiable anymore. You cannot instantiate it anymore. That's why they call it an abstract-based class. You know what abstract art is? Ever seen abstract art? You go over there and say there's a triangle with 2 circles. And say, what is that? That's a lady dancing. That's what it is. So an abstract thing is essentially an idea. Okay? You cannot instantiate it. It doesn't exist. It's just an abstract view of yours. And that's why we call this an abstract-based method. So an abstract-based, a pure virtual method, it's a class that cannot be instantiated. You can inherit it. When you inherit the sound, now the cat and dog can get instantiated, but animal cannot. And when I look at my implementation of a dog and a cat, I'm going to say a cat is going to say meow, and a dog is going to say woof. Oh, dog said woof, woof. Okay, twice. But anyways, so dog says woof, cat says meow. These are not abstract. These are what we call these concrete classes. A concrete class is a class that doesn't have a pure virtual method. An abstract-based class is a class that at least has one pure virtual method. It means you cannot create it. You cannot instantiate. And sometimes a system analyst, a designer, sits over there and creates a class, and the class is only an idea, which means it sits over there, looks at the class, and just writes the list of methods this class is supposed to do, all equal to 0. No implementation, just design. And creates a destructor at the end, makes that one virtual equals to default, not 0. Destructors cannot be 0, because if the destructor doesn't exist, the object cannot get destroyed. So destructors must exist. So you write virtual, you put destructor equal to default, not 0. It means it's a default destructor and it's virtual. That class that only has pure virtual methods in it, we call that an interface. An interface, and it doesn't exist in C++. C++, interface, abstract-based class, potatoes, potatoes. In C++, it doesn't matter if it's one or if it's all. Yes? Oh yeah, that's the idea. If you don't inherit it, what's the point? The whole so you see that what happened over here, right? So when I actually go to the source code of this one, when I look at this one, if I wanted to create the animal, it would have given me an error, telling me, hey, an animal is an abstract base class. You can't instantiate it. Take a look. If I actually do this, it literally tells me over here, object of abstract class type yada yada is not allowed. It's an abstract thing. You can't do anything. So I'll remove it, run it. So as you see, I have an array of 4 animals, 2 cats and 2 dogs. And they're all animal pointers. So what I do, I come over here, I say, make a sound, first one make a sound, second one make a sound, third one, fourth one, and automatically the proper one is selected. They are all animals, but they're different types of animals. And when I'm deleting them, each one is going to get deleted properly. And then it comes out, the last one gets deleted. So as you see, the proper action is selected. Now, if I want to look at the interface one, this is what it's going to look like. As you see, I have an animal. And when you look at my animal, this is what I have. An animal, it doesn't have anything. An animal can act, move, make a sound, and it has a virtual thing. That's it, nothing else. It's just an idea. But then out of an animal, I create a pet. Now, a pet has lots of stuff. It implements move and sound, but it didn't implement the act. So pet is still an abstract base class. It's not an interface, but because it didn't implement the pure virtual method act, it's still not instantiable. You cannot instantiate this. And then out of pet, I'll create the cat. Now, cat is the one that I can actually. So in cat, all I needed to do was implement the act. I didn't need to implement the move and sound. I just did it because it's a cat. Okay? So that's how it is. So essentially, that's how everything works in inheritance. And interfaces mean something in object orientation. In C++, they didn't find the need for it to make it different with anything else. But you will see later on that interfaces mean actually something. So that's that. That's the whole gist of the. So I just went more and created lots of different things in it for you to see. So what is this? So array of interface pointers. So you run this. It's, you know how it's going to work. So this is. So essentially, when I look at the source code with the one with an interface. Oh, and one thing I have to mention, virtuality is transitive. Anybody knows what is the meaning of transitive? It means it passes its capability to the next one. So if you have an act that is virtual, all the acts through the hierarchy of inheritance become virtual. Which means if I have an animal and a pet and a bird and a baji, then if I refer to a baji as a bird, it's still virtual. The act is still virtual. If I refer to a baji as a bird, it is still virtual. If I refer to it as a pet, still virtual. If I refer to it as an animal, even if the virtual is not mentioned. But it's a good idea to do it when you are overriding a virtual method, just as a courtesy for the next person who might use your derived class as a base class of its own, to know this is actually a virtual. It's a good idea to put in front of it, but if you don't, it doesn't matter. So now cat is created, and it's a pet that is a cat, and I have the reference and everything for it. And it works as you can expect. So cat is a cat. With animal reference, they all work like a cat. With animal pointer, the same. As a pet is the same. So they all work properly in a hierarchy of inheritance. And that's interfaces for you. And finally, after this, everything else is just examples of what we had. So let me just add those two too. Now, so I'm going to say over here, add. You're scaring me, man. Yeah, it's recording. Oh, yeah, okay. So what I wanted to say over here. So let me bring the other ones in. Add existing project 8. These are all different. So by the end of interfaces, everything's the same. But let's look at this one. So if you look at this, you have lots of stuff in here. And where's my? So let's set this thing as startup project. Add new item. I think it's utility class diagram. Oh, already exists. Okay, let me just. Okay. So we're just going to drag all these guys. And drop them in here. There you go. So that's my animal kingdom. I have an animal as a base class. That's an interface. Then I have a pet that is created out of that one. Then I have a cat, a bird, and a goldfish. And then I have a budgie over there. So maybe it would have been better to actually have over here canines and felines. And then from canines, we could have, I don't know, different types of different kind of dogs like poodles and Dobermans and things like that, and go with that. So I don't want to do that, but just this is what it is. And it has all the constructors, destructors, and everything, and also the overload for. So if you come over here, you will see that O-stream operator. You see that? I see people talking. You see this? Overload for animal that I have over here. Usually interfaces, they don't have a CPP because they don't have any code. But this animal has a CPP actually, and the CPP for this animal only contains the overload of the thing. So it essentially calls the pure virtual methods. Since I did this, I do not need to overload this for any animal, because any animal passed to this will execute the proper method because they are virtual. And that's lots of time to be saved. Okay? That's that. Questions? Suggestions? Objections? Okay. I'm going to post it right now, so yeah, so I'll make sure that it's not going to get lost. So, and there are lots of code in there, so it's going to take a while. Inheritance virtuals interfaces. Yeah, all of it. There you go. They're all up. I beg you to please open up every single solution, walk through it as I exactly mentioned, go through it and understand how they work, and it's going to be fine. This is done. What we need to do now is give you guys a little bit of break. You come back, then I'm going to talk about milestone 3. So, okay, I'm going to go through milestone 3 and tell you exactly what they are. So you have a good start with it. Okay? Break, 15 minutes. Let me just save this. Stop.